Hello everyone. So this is the problem cutting votes, where we have where we have given height of the votes. So uh, the zero wood number zero is of height 2, wood number 1 is of height 6, wood number 2 is of height 3, wood number 3 is of height 8, and the target we have given as 7. We need to find the maximum wood according to the height. So the output is 3, because as of height 3 we are getting wood number 1 has a maximum wood of 3, and from the wood number 3 we are getting maximum wood of 5. If we sum those both values we are getting 8, so which is greater than or equal, which is greater than 7. So this is a valid answer. So how to do this? We will apply the binary search to solve this problem. Basically the idea is to find the upper bound, uh, and to find the mid we would do as mid is equal to left plus right minus left divided by 2 plus 1. Why we are doing 1? Because it gets stuck into the infinite loop. So we need to get out in and we need to get out from the infinite loop. We are just adding plus 1. So let's do the dry run of this and understand why we are doing the plus 1. So uh, now we are having left is equal to 0, right is equal to 8. We are getting the maximum value from this array. Now using the normal mid formula, we are uh, left is equal to 0, right is equal to 8. We are getting the mid as 4, which is less than 7. So we are shifting the right is equal to 3. Now the new value comes as left is equal to 0 and the right is equal to 3, where we are getting the mid as 1, which is a valid answer, we, which is greater than 7. Now we are shifting the left is equal to 1. So the left is 1, right is 3. We are getting mid as a 2. This is also a valid answer. Then after getting the valid answer, we are shifting the left is equal to 2. Uh, Left is equal to 3, 2, right is equal to 3, mid is equal to 2, which is also a valid answer. Now, if we want to get the new range, uh, we are getting left is equal to 2, which got stuck into the infinite loop. So by adding uh, plus 1 makes the sure that mid is biased toward the right half. So that when we do left is equal to when we do left is equal to mid, left always increases. Uh, so to get the maximum value, we will just do left is equal to mid to avoid the infinite loop. So by now let's try run the now let's try run using the method using the biased right formula. Left is equal to 0 and right is equal to 8, where we are getting mid is equal to 5, which is not a valid answer, so we are shifting it. Right is equal to 4. Now left is equal to 0 and right is equal to 4, where we are getting mid is equal to 3. This is a valid answer and this is also a greater than 7. Why? Because if we calculate it, 3 plus 5 is equal to 8, which is greater than 7. So we are shifting left is equal to 3. Now left is equal to 3, right is equal to 4, and the mid is equal to 4. Where we are getting mid is equal to 4, which is not a valid answer, and we are making right is equal to 3, which is violating the condition, and we are getting out of the loop, and we are returning the valid answer as 3. So the time complexity of the binary search is, we all know, is log of n, log to the base n. So the pseudocode would be get, first we need to get the maximum uh, value from the array, and we are making this value as the right. Now we need to run the while loop containing the binary search where left is equal to 0 and right is equal to 8. Now we have the condition to check if cuts in a food, where we are passing three arguments, mid and k and height, uh, where we are checking if height is greater than cuts, then we will store the collected wood. Collected wood is a variable. We are just storing all the collected wood, like we are storing 3 and 5, which will make 8, and we are returning if the condition gets satisfied, collected wood is greater than or equal to k. So if it is true, then we are doing left is equal to mid, otherwise right is equal to mid minus 1. So now let's do the problem. So we have defined a array here, and we have made the k is equal to 7, and we are getting the result from this method, and we are printing it. Uh, so now let's apply the binary search here. So in the cutting wood method, we are passing the two arguments where the parameter is height of arrays and integer of k. We are defining the left is equal to 0, and we are getting the maximum value from this array, where we are storing it as a right in the right variable. We are uh, we are doing the while loop. The condition is like left should be less than right. We are getting the mid. It is a biased mid. We are uh, we where we are checking the condition. If this condition may if it's equal to 3, we are cutting more. uh, we are uh, we are getting the boolean value. If int is equal to if collected wood is we are just define we are initializing the wood collected is equal to 0. We are running the for each int is where the condition is num should be greater than h is equal to h is the mid which we are getting it from this formula. It should be the greater than it should be the less than num. So we are collecting the wood by doing the subtraction height minus h, and we are returning wood collected is equal to is if it is greater than or equal to h. Now let's run the program and see. uh, it should be we are get struck now. Cannot be referenced. Okay, I forgot to make the static. uh, so I got the problem. We need to compare it with the k. Now let's see. Okay, 3 has come. So this is uh, so the time complexity is big of log n, log to the base n. So thank you. Please subscribe this channel.